All right, guys, good afternoon or morning whenever you're watching this. Today, we are going to be still hanging out on a circle, but we are actually going to be looking at our trig functions again. So sine, cos, tan, cosecant, secant, and cotangent. Yesterday and the day before, you guys were working with angles in radians and degrees along the unit circle. We are eventually going to connect this back to that, but today is going to kind of be its own thing for now. Okay, so we have here in this picture a circle with a triangle and a point, because of course we do. What we're going to be doing is we are going to be starting with a point, and it is going to be a point that lies somewhere along this circle. We are going to be finding from this point, we are going to be finding actually the radius of the circle. And we're going to do that because we're going to have this handy dandy triangle drawn for us. And we're going to realize that, oh, hey, we can just use Pythagorean theorem to solve for this radius. So here's what I mean. This point x, comma y, this x is the horizontal distance. And this y is the vertical distance. So in terms of this triangle, your triangle, that's really, really big. Your triangle actually is that horizontal distance x and that vertical distance y will, together with the radius, create a right triangle. So that's why you have a right triangle here. The radius of the circle, by the way, is a radius because it starts in the center and then it goes to the outside. So part one is you're going to draw a triangle, you're going to label x, you're going to label y, and then you are going to solve to get r. And the way you're going to do that is this is a triangle. Hello, Andrew Brissett. Goodbye, Andrew Brissett. And you are going to use Pythagorean theorem to solve for that radius of that triangle. And so you're going to use Pythagorean theorem, to solve for this r. I know this all is a little weird. It's going to make a ton more sense with actual numbers, so just sit tight, and then it hopefully will make a little bit more sense. Okay, so I have an r, an x, and a y. That's cool. What am I doing with this? Well, if you notice, you're going to be finding sine, cos, tan, cosecant, secant, and cotangent. And the way you're going to do that is you are going to use the fact that, for example, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I'm sure we all remember that, of course. If not, here it is. And so what we're going to do is from this theta that's right next to that 0, 0 point, the origin, we are going to label our opposite, adjacent, and hypotenuse. So I already know the radius is along the hypotenuse. So that radius is the hypotenuse. And I also know if theta is down here, then across from theta on the opposite side of the triangle will be the opposite side, and then x will be your adjacent. And so all together, once I've drawn this triangle, your opposite side will be y, and then your hypotenuse will be your radius, r. For cosine, sort of similarly, your adjacent is x, and again, your hypotenuse is r. And then for tangent, your opposite is y, and your adjacent is x. And then for our cosecant, oopsies, and our secant and our cotangent, remember these are just reciprocals, so we will simply flip them. So swap the y and x, swap the r and the x, and swap the r and the y. Okay. So to kind of clean this up a little bit, whenever we have a point x comma y, we can write our trig functions using these formulas. And so we are going to do that right now. And again, if you're like, I don't understand what is happening, just sit tight. We're going to do this with numbers right now. Okay. Feel free to pause if you need to catch up on writing this, but video is going on. Okay. Excuse me. So we are going to start with this guy right here. Number 1, which says the point, oopsie, there we go. The point we are looking at is -4, 3. So I am going to roughly estimate where this point is. We don't actually care where you put the point as long as you put it in the correct quadrant. So I know I'm going left 4 and I know I'm going up 3. So I'll go to the left, I'll go up, and I'm just going to throw this point right about right there. Okay, so this point is going to be -4, 3. Okay, so I'm throwing my point somewhere on this circle right about there. I know it's left, I know it's up. Then what I'm going to do is I'm going to draw a vertical line connecting that point to the x-axis. And then I'm going to draw a horizontal line connecting that point back to the x-axis as well. And then finally, because I know I'm using a triangle, because opposite, adjacent, etc., I'll connect my very curvy hypotenuse back to the point right there. And now I have made myself a right triangle. Lastly, I'm going to label my vertical and horizontal distance. And so my horizontal distance is -4. And my vertical height here, my distance is 3. Again, 3 is my y, and -4 is my x. Okay. So then lastly, I need to go ahead and I need to find this value r. And so the r I know is going to be right here. That's my radius. And so I'm going to calculate that r by doing Pythagorean theorem. So r is going to be equal to, so r squared, I should say, is going to equal 3 squared plus, and I'm actually going to include the -4 here, -4 squared. Okay. So 3 squared I know is 9. -4 squared, yes, it is negative, but I'm squaring it, so it's going to turn positive. So this will turn into positive 16. And then 9 plus 16 is 25. So r squared is equal to 25. Finally, to get r by itself, I will square root. I'm just doing Pythagorean theorem here, people. Yay for us. So my r is equal to 5. Okay. So I have my r, I have my x, that's -4, and I have my y, which is +3. And so I have x, I have r, I have y. If I scroll back up and look at my little formula for writing my trig functions, I have everything I need. I have an x, a y, and an r. And so now I'll just go ahead and write my trig functions. And then I'm done. So it looks like sine of theta is equal to, sorry if my changing of color is bothering you. Can't decide. Okay. So it looks like sine of theta is y over r. So we'll go back down. We'll go back down. Nope. Sorry guys, I'm trying a new thing. It's not really doing what I want. Okay, there we go. So we see that sine is y over r. And so we'll just go ahead and write y over r. So y is 3, and r is 5. And so 3 over 5. Nothing can reduce. I don't need to move a root. I'm good to go. Cosine is x over r. So that's going to be -4 over 5. And yeah, I'm going to definitely include that negative because I am looking on the left side of an XY axis. And so even though distances can't be negative, we definitely need to include that negative so we know which position this triangle is in. And then finally, tangent is y over x. And so that's going to be 3 over negative 4. Finally, we'll go ahead and flip these 3 to get our reciprocal functions. So cosecant is 5 over 3, secant is 5 over negative 4, and cotangent is negative 4 over 3. Okay. So that is what the process looks like. Now, will all of your points be perfectly nice and get a nice even R, whole number R, like 5? No. And so that's going to bring us to example 2. So I would like you guys to pause the video and try to get as far as you can on example 2. And then when you resume, we'll go ahead and check your answers. Okay. All right. So I'm going to start by graphing my point approximately 1, negative 2. I know I'm going to the right 1 and I'm going down 2. And so I will go to the right and I will go down, and approximately my point is like somewhere right there. Maybe not. It doesn't really matter. We don't super care about where you draw your point as long as it is in the right quadrant, and this should be in quadrant 4. Okay, so I will draw a line from my point to the x-axis. If you drew a point to the y-axis, that is bad. Don't do that. Okay. Instead, you're going to draw a point to the x-axis, and then we'll draw another point back, connecting from where you hit your x-axis back to the origin. And then finally, we will connect that and make a very ugly looking triangle. The length, the height here, we'll go with the y first, is down 2, so that is negative 2. And then the horizontal distance is positive 1. And so now we need to go ahead and find our r. And so doing it the same way as before, I have r squared is equal to 1 squared plus negative 2 squared. So here r squared is going to be 1 plus positive 4. R squared is equal to 5. And then I'm going to square root 5. I cannot simplify that square root of 5, so it is just going to stay root 5. So our r is root 5. Okay, so our r is root 5. Let's just color coordinates went up. Our x is 1, and our y is negative 2. So now we're going to go ahead and write our trig functions the same exact way. So let's do it. So for sine, it is y over x, and so that, or sorry, no. It's y over r. There we go. Y over r. And so that's going to be negative 2 over root 5. And if you're like, uh-oh, good, that's good. There is an uh-oh. We'll come back to that. Cosine x over r, so 1 over root 5. And tangent is y over x, which should be negative 2 over 1. So we'll flip those to get our other 3, and then we got to do some work here. So for cosecant, that's root 5 over negative 2. For secant, root 5 over 1. And then for cotangent, that is 1 over negative 2. Now, a couple things we need to clean up. I'm sure you know. I'm sure you see it. I'll go blue. So first thing is my tangent and my secant that have something over 1. Let's not write that. Let's just write negative 2. And let's just write negative 5, or sorry, root 5, excuse me. Okay. 1 over negative 2 is fine for me. I'm good with that. And 5 over negative 2, I'm also good with. Those are good. However, sine and cos, I cannot have, no, a root on the bottom of a fraction. And so I need to multiply top and bottom by root 5. And again, if you know the shortcut, use the shortcut. We do this too much. So this should end up being -2 root 5 over 5. That'll end up being your sign. And then this guy will actually be 1 root 5, or just root 5 over 5. And again, there's a 1 there, but you don't need to write it. Okay. So if that's what you got, you're looking great. Okay. So that leaves us with the third one. And this actually is your work for today, or your homework for this part. So you need to do this one. So you try this. So this is your check your understanding for today. You just get one of them. So you're going to go ahead and plot the point -5, 7, and then do your thing. Lastly, what else do I need to say about this? I think nothing. I think we're okay. Once you're done with this, you are welcome to work on your Pi Day poster if you're planning on doing that. Otherwise, if you need to catch up on missing stuff, try working on that stuff. And yeah, hope you guys have a pleasant Friday or whenever you watch this. Enjoy.